right, let's build a complete learning roadmap for application programming interfaces, or what you'll almost always hear called APIs. We're going to cover everything from the absolute basics all the way to the advanced patterns that tie modern software together. And we'll do it all in just a few minutes.
So let's kick things off with a simple question that really gets to the heart of our digital lives. Think about it. How do all your different apps actually talk to each other? Well, the answer, almost every single time, is an API.
Okay, so let's start at square one. We need to build a really clear foundation of what an API actually is and why it's become this fundamental building block for pretty much all modern software. The easiest way to think about an API, it's basically a messenger. It takes a request from one app, goes over to another system to get what it needs, and then brings a response right back. It's the invisible engine that makes our connected world go round. Now, what's really interesting here is how APIs are broken down based on who gets to use them. You've got public APIs, which are open to everyone. That's how your favorite weather app gets its data. Then you have private APIs, which are only used inside a company. Think about how a bank's mobile app talks to its own internal systems. And finally, partner APIs are for specific business deals, like how Uber uses Google Maps to show you where your ride is. Okay, so now let's talk about the different architectural styles. You can think of these as the design blueprints for building an API. And the style you pick? Well, that depends entirely on what job you need the API to do. And this table just lays it out perfectly. You've got REST, which is kind of the workhorse of the web, super common and reliable. Then there's GraphQL, which is much more flexible. It lets an app ask for exactly the data it needs and nothing more. For really high-speed communication inside a company's own network, you've got gRPC. And for real-time stuff, like a chat app or a livestock ticker, WebSockets are the way to go because they keep that connection wide open. So, we've got the blueprints down. Now, what does it actually take to build a great API? One that's robust, secure, and one that developers actually enjoy using. Let's get into the essentials. Since REST is the big one, you've got to know its basic moves. These four methods, post, get, put, and delete, are like the verbs of the API world. They let you create, read, update, and delete data. It's that simple.
And this is a big one. You absolutely positively cannot have a great API without rock-solid security. It's not something you tack on at the end. It has to be baked in from the very beginning, because even one small vulnerability can expose tons of sensitive data and just completely destroy trust. And you can really see the evolution in security right here. We've moved away from older, kind of leaky methods like basic auth to the modern industry standard, which is OAuth 2.0. Instead of sending a password over and over, OAuth uses secure, temporary digital keys that can be revoked at any time. It's just a much, much stronger way to protect data. Now, here's a point I really can't stress enough. An API is only as good as its documentation. Seriously. If developers can't figure out how to use your API, they just won't. That's why tools like Swagger and Postman are so essential for creating clear, interactive instructions.
Okay, so beyond the basics, these are the features that separate a good API from a truly great one. Pagination stops you from getting overwhelmed with data by serving it up in smaller pages. Versioning lets you improve your API without breaking all the older apps that depend on it. And idempotency, I know, it's a fancy word, it basically just means an API is resilient. You can send the same request multiple times without worrying about accidentally creating duplicate orders or double charging someone.
Look, performance can make or break an API, period. That's why these practices are not just nice-to-haves, they're essential. Caching makes things way faster by storing common data nearby. Rate limiting is what stops a single user from hogging all the resources, which keeps things stable for everyone else. And load balancing, it's like a traffic cop, making sure requests are spread out evenly so no single server gets overloading.
All right, for our final section, let's pull back and look at the bigger picture. Let's see how all these different pieces fit together in the broader API ecosystem. So, what's an API gateway? Just think of it as an air traffic controller for all your APIs. It's a single, managed front door that handles all the complex stuff like traffic routing, security checks, and monitoring. It really simplifies everything happening behind the scenes.
Now, the great news is you almost never have to build an API completely from scratch. Frameworks give you a massive head start. Whether you go with the lightweight Express.js for Node, the super powerful Spring Boot for Java, or a crazy fast option like Fast API for Python, choosing the right framework is a huge decision.
And finally, you start to see how APIs are literally the glue that holds modern systems together. They can work synchronously, where you need an answer right away, or asynchronously, kicking off a long task that just runs in the background. They make real-time updates possible using webhooks, and they make sure every message gets delivered reliably with things like message queues.
And there you have it, the complete API roadmap. This isn't just some niche topic. It's a critical skill that over 1 million developers, architects, and tech leaders are actively learning and mastering to build the software of tomorrow.
So that wraps up our journey through the world of APIs. As they continue to connect everything in our digital lives, it leaves us with a final, fascinating question to think about. What is the next leap forward in how our world communicates?